Problems for section 3.4, these practice problems. Some of these we may have done in class and others not. I'm going to go through them pretty fast, so you can just skip to the problems you need or replay what you need to get a full understanding. So in this case, I'm solving for x, so I'm going to add 3 to both sides, leaving me minus x on the left. Bring down the symbol just as is. The right-hand side is 0. Now I have a negative out in front of the x, so I have a choice here. I can multiply both sides by -1 or divide by -1. I prefer to do the division. And when you divide by a negative number or multiply by a negative number, remember you have to flip the sign. So on this one, the x, it's x, positive x on the left. I have to flip the inequality sign. On the right-hand side, 0 divided by -1 is just 0. So there's my solution for that. All right, the next one, I have variables on both sides. I like my variables to be on the left-hand side. Now I can see here that I'm going to create a negative coefficient, but that's okay. I'd rather have my variable on the left and worry about the negative coefficient in a minute. So I'm going to bring down that -5, leave the sign as is. Okay, let's keep going. I'm going to add 5 to both sides. And I have -9x is less than or equal to, what is this, 18? Now I have to divide by -9 on both sides. Since I'm dividing by a negative number, I have to flip the sign. And I'll do that in my last step here. I got x. And I'll rearrange this sign where it's greater than or equal to. And on the right, I have -2 or -2. Okay, the next problem. I have some choices here. I need to clear this fraction. I could clear it first, multiply both sides by 4. When you do that, you need to make sure you also multiply the 2 by 4. I prefer to just move that 2 out of the way first, so that's what I'm going to do. This leaves me x over 4 on the left. The sign stays the same for now. 3 minus 2 is 1. Now I'm going to multiply by 4 on both sides to clear that fraction. 4's cancel. I have x is greater than 4, the final answer. Okay, next one. I have whole numbers on both sides. I got my variable on the right. No other variable to combine that with, so I'll just leave it there for right now. I'm going to subtract 11 from both sides to get started. On the left, I have -4. Bring down the symbol, the inequality symbol. I got 8x on the right. I'm going to divide by 8 on both sides. On the left, I have, if I reduce that fraction, I have -1/2. Bring down the symbol. On the right, I have x. You can leave your answer just like this. I like the variable on the left-hand side, so when I move this variable to the left, I'm going to keep this symbol the same orientation as it is, with respect to the variable x. So the pointed side is on the variable x side, so I have to basically switch that around. The open side is on the -1/2 side, so I have to leave that way. Now, you don't have to flip this around if you don't want to. I prefer to do it that way. All right, on the next problem, again, I have whole numbers on both sides, so I'm going to subtract that from both sides. On the left, I have -12. Symbol stays as less than. On the right, -3x. I have to divide by -3 on both sides, and when I do that, of course, I have to flip the sign. This gives me a +4 on the left. Flip the sign around, and on the right, +x. You can leave the answer like that. I'm going to do one more step. I'm going to bring that x to the left, pointy side at the x, open side at the 4, just like that. All right, the next problem. Again, I have, kind of like in number 3, I have a fraction and a whole number. Actually, I'll solve this one the other way, just give you a different view from what we did in number 3. I'm going to clear the fraction by multiplying both sides by 2. Now, when I multiply by 2, I have to distribute the 2 into this binomial. So 2 times 4 is 8. 2 times negative 3 halves, the 2's actually cancel here, and I'm left with minus 3x. And I have 26 on the other side. I'm going to subtract 8 from both sides, and that leaves me minus 3x less than, what do we have here, 18. I'm going to divide by negative 3 on both sides, and because I'm dividing by a negative, I have to flip the sign, and I get x, flip the sign, greater than negative 6. All right, let's try some more. On the next one, I have variables and numbers on both sides. I like them on the left, so I'm going to move this, add x to both sides. 3x minus 6 greater than 3. I'm going to add 6 to both sides. And I get 3x greater than 9. Divide by 3 on both sides. X is greater than 3. That one turned out pretty straightforward. All right, let's try this one. I want my x's on the left, so I'm going to add 10x to both sides. That gives me 5 plus 2x over there. On the right side, I have 19. Minus 5 on both sides. Gives me 2x less than or equal to 14. Divide by 2 on both sides. I get x less than or equal to 7. All right, let's keep pressing on. Have some decimals here. All the rules are exactly the same as they are with whole numbers or fractions. I'm going to add 5.48 to both sides. That gives me 4.7x is greater than or equal to, let's see, what do we have here? 0, 1, 8, 18.8. I'm going to divide by 4.7 on both sides. Everything's positive, so nothing strange happening here. And let's see, what is this going to equal? Does this equal 6? I do not have a calculator with me, so let's see, 4.7 times 6. I don't know if it goes in there equally, and it doesn't. Oh, that's way too big. Oh, should be 4 times. Let's try 4. 16, 18. That's it, 4. Okay. All right, next problem. We have quite a bit of distributive property I got to deal with. I'm going to go ahead and put in all my arrows. And here we have 9p minus 15 plus 8 less than or equal to 8p plus 8 minus 2p plus 6. This problem is very similar to the homework problem. I'm going to combine like terms there. I have like terms here and here. So I'm going to do all of that in my next line. 9p minus 7 is less than or equal to 6p plus 14. Add 7 to both sides. I get 9p less than or equal to 6p plus 21. Usually I do my variables first. I must have overlooked that. I must subtract 6p from both sides. I get 3p is less than or equal to 21. Divide by 3 on both sides. P is less than or equal to 7. All right, let's keep going. Now we have some fractions. All right, here I need to make a common denominator. Not a common denominator. I need a least common multiple so I can clear the fractions. So I'm going to start with the biggest number, 8, and check to see if all these numbers go into 8. 6 does not. It doesn't go in evenly. So I'm going to multiply that by 2, and I'm going to try 16. 2 works. 6 does not work. Let's add another 8 here and try 24. 2 works, 6 works, 8 works. We're good to go with 24. So I'll multiply both sides by 24. Now when I do that, I have to distribute the 24 into each of these binomials. All of those. Let's do it. 2 goes into 24 12 times. 12 times h is 12h. 6 goes into 24 4 times. 4 times negative 5 is negative 20. The symbol is less than. 8 goes into 24 3 times. 3 times 5 is 15. And 24 times h is 24h. All right, I'm going to subtract 24h from both sides, even though it's going to present with a negative coefficient out in front. That's okay. That's the lesser of the evils in my mind. Okay, I'm going to add 20 to both sides. And this is not going to come out pretty, but that's okay. That happens sometimes. Minus 12h is less than 35. I've got to now divide by negative 12. I've got to flip the sign. And that gives me h is greater than, this is a fraction, so negative 35 twelfths. Not really anything else we can do there. Okay, on the next problem, it's a little bit simpler. It only has one fraction, so I'm going to clear the fraction just by multiplying both sides by 2. And actually, this 2 doesn't need to be distributed because it clears with that single value in the denominator, leaving me 3x minus 4 is less than 14. And this is just a little two-step problem we can finish up here. 3x is less than 18. Divide by 3 on both sides. X is less than 6. Okay? All right, the next one, a little bit more complicated. I need a least common multiple. So I have 5 and 3, so I'm going to start with the bigger number. Obviously, 5 is not going to work for the 3. 10 also doesn't work for 3. I'm going to add 5 more. 15 will work. So I'm going to multiply both sides by 15. Now this is a little tricky because pay attention to what happens here. On the left, I'm going to cancel the 5, and that leaves 3 there. Okay, so now I need to multiply the 3 times the 6. So this is 18 times the binomial x minus 2. I don't want to distribute the 3 into both of these parts. Once you multiply the 3 times 6, you've used up the 3. This was supposed to be a 15 here. Okay, and in a similar way, 3 goes into 15 5 times. 5 times 10 is 50. And then the binomial is still the same. Let's distribute each of these, giving us 18x minus 36. On the right, we have 100 minus 50x. I'm going to add 50x to both sides. So that gives me 68x minus 36 is greater than 100. Add 36 to both sides. Gives me, I'm going to work over here, up here. Oh, I got a lot of room on the right. Here we go. 68x is greater than 136. And nicely, 68 goes into both of those numbers. So I get x is greater than 2. Okay, a couple more problems here. This we have embedded parentheses. So we need to be really careful. We're going to work inside out on these parentheses. I'm going to start right here. Got a negative out in front of this set of parentheses. I'm going to distribute that. And at the same time, I'm going to go ahead and rewrite the right side by distributing that one. So I'm going to write this 4 down in front, keep the bracket, keep the x, and now I'm going to write minus 3x plus 2, close that bracket, greater than, here we have 3x plus 15 minus 18. Now what I'm going to do is I'm going to combine like terms here as my first step. Actually, I'm going to write this. I'm going to take a little bit of a shortcut here. I'm going to write this right underneath here, and this will be minus 2x plus 2. So I'm just writing that portion, and now I'm going to distribute this here. Okay, so I kind of did 2 steps at once. As long as you're nice and neat with your work, I think this is a totally acceptable way to take a shortcut here. All right, 4 times negative 2x is minus 8x. I meant to grab this color. 4 times 2 is plus 8. that is greater than, and then let's combine these like terms, 3x minus 3. All right, we'll keep working here. I'm going to subtract 3x from both sides. This gives me minus 11x plus 8 is greater than minus 3. I'm going to subtract 8 from both sides. I'm going to write this over here. I have minus 11x is greater than minus 11. Divide by minus 11 on both sides. And since I'm dividing by a negative, I have to flip the sign. And I get x is greater than 1. Okay. Similar problem. On this one, the left-hand side, there's not really anything to clean up there, so I'll just copy it down just like it is, bring down that. Here, the parentheses inside these parentheses don't really mean very much. Inside the bracket, I need to combine like terms, so I can actually combine this x and that minus 2x. I'm going to leave the 3 out in front. I'm going to leave that bracket for now. X minus 2x is minus x. Bring down the plus 2. Close those brackets. And then bring down the minus 1. Remember, you're working inside out. Now I can distribute the 3 inside. And I'll have a little bit more cleaning up to do on the right side. So left side as is. Here we have minus 3x plus 6 minus 1. I can combine those like terms. So I got minus 3x plus 1, minus 3x plus 5. Let's add 3x to both sides. I lost my color pattern. Oh, the x's are gone. And I have 1 is less than 5. And that is true all day long. So since that is true, that tells us that any number would work for x. So the solution is x is all real numbers, or you could say all real numbers. We could even write it in notation, interval notation, that way. Okay, there you go. That's it for the homework, for the review. Good luck with your homework.